Hello, my name is Beth Dixon, and I am the Math Lab technician and work in the Math Lab in the MBSS 222, the Math and Behavioral Social Science building. And this is a couple of examples on solving equations with one step. These lessons are not to replace your lectures, but to help supplement them and give you a few more examples to look at and maybe some extra help as you're watching them. So let's look at these examples. And again, these are for one-step equations. So let's look at the first one here. And I have x minus 5 equals 3. And I'm starting with one that we can look at and have an answer for. In other words, this is one that most of you can look at and tell me that the answer is 8. When I taught this class, a lot of students said, well, why can't I just write x equals 8? I can see that. But one of the things I want to tell you is that learning the procedures now will really help you later in that when you can't solve them, when the arithmetic is a little bit harder for you, i.e. the positive and negatives don't just jump out at you but to tell you what the answer is, you'll have learned what the procedure is. And two, not all equations can be solved this quickly. Eventually, we won't expect you to show the work for every problem when you're in 0850 or finite. If you can get this far and then know that the next line and what the answer is, that's fine. But to start out, we really want you to show every step so that you're showing us that you get the concept as well as just knowing what the answer is. So again, it's very important that you show these steps. And the first step is to remember that in solving an equation, we're working the order of operations backwards. We're undoing the order of operations. There was some x, and we subtracted 5 to get 3. So what did we do to the 3? Well, we subtracted 5 from a number to get the 3. So to figure out what that number is, we do the opposite. We're going to add 5. And to show that, we're going to show 5 added to both sides. What that does is allow us to undo that subtract 5. Adding 5 and subtracting 5 are inverse operations, and that undoes that operation. That leaves us then the x on the left-hand side by itself. On the other side, we then have 3 plus 5, which of course we know as the answer to be 8. And we've solved this equation and used the process to do so. Let's look now at another example. And again, this is another example where we can probably look at the equation and tell what the answer is. Whoops. Again, throwing up things we don't need. X plus 6 equals 14. Again, we can look at this and say, well, what do we add to 6 to get to 14? And we know it's 8. But again, we're worried more about the procedure. And again, we're working in reverse of the order of operations. We have a number x. What do we add to x? 6. And that gives us our answer, which is 14. So how are we going to go backwards from this and undo that? Well, we're going to do the inverse, which is to subtract 6 from both sides. That then lets us to cancel out the 6's. And again, canceling is not a good math term, but it is what happens here. That's the inverse of adding 6 is to subtract 6. And then 14 minus 6 gives us 8. And on the left-hand side, we're left with the x. And we've applied the rule that the inverse of addition is subtraction, and the inverse of subtraction is addition. So addition and subtraction are inverse operations of each other. Think about it in real life. The opposite of adding something to your pot is to take it away. The opposite of taking away something is to give it back. So addition and subtraction are inverse operations. Now let's look at a couple where we can't just look at them and tell what the answers are. These are going to involve some positive and negative numbers. Let's start with x minus 7 equals negative 3. And again, the idea here is to add 7 to both sides. Why do we add 7? Because x has been subtracted, and the inverse operation of subtracting 7 is to add 7. Those cancel, and we're left with x equals, and then we perform our operation on the other side. What's a negative 3 plus 7? The signs are different, so we find their difference, which is 4, and then keep the sign of the stronger number, which is 7, so the answer is a positive 4. Now, in the others, I didn't check the answers because the answers were obvious. But in this one, let's do a quick check. 4 minus 7 equals negative 3. Well, 4 minus 7, the signs are different, so that gives us to subtract and keep the sign of the larger, which is negative. So a negative 3, well, that looks like a B. 3, and keep the sign of a negative, and that gives us then equal to a negative 3, which is the correct answer. So it does check out as well. Okay, let's go on to the next one. X minus 3 equals 8 minus 16. Notice this one involves something that we need to do first, which is to simplify. Now I'm only doing the simple one-step equations here. There will be some in your homework that may be involved in more complicated ones. But the first step would be to simplify both sides in adding any like terms. Any x's need to be added to other x's. Any variables need to be added to other variables. In this case, the numbers need to be added together. And I may have just said that wrong. But numbers need to be added to numbers, variables need to be added to variables. And in this case, we have two numbers, 8 and 16, that we need to actually do that subtraction. The x and the minus 3 need to stay the same, and then 8 minus 16 will give us a negative 8. Again, the signs are different, so we subtract and keep the sign of the stronger number. Then the next step is to undo the subtract 3. We're trying to isolate that x. And the first step is to always undo any addition and subtraction. Subtract 3, the inverse operation is to add 3. So let's put plus 3 on both sides. What we do to one side, we always have to do to the other side. That gives us x over here on the left-hand side. And on the right-hand side, we have a negative 8 and a positive 3. The signs are different, so we subtract the numbers and keep the sign of the stronger number, which gives us a negative 5. Again, we can do a quick check on that. A negative 5 minus 3 is the same as 8 minus 16. The signs on the left-hand side are the same, so we'll add and keep the sign. On the right-hand side, the signs are different, so we'll subtract and keep the sign. And since negative 8 does equal negative 8, we know that we've got the correct answer. Okay, let's look at the other type of one-step equations that we have. And those that are the ones that involve multiplication and or division. Just like addition and subtraction are inverse operations of each other, multiplication and division are inverse operations of each other. One will undo the other in either direction. If something's been multiplied, we want to divide by that number to undo it. If something's been divided, we want to multiply to undo it. So let's look at my first example here, which will be 2x equals 14. Again, I've picked one to start out with that we can look at and get the right answer. We know that x has to be 7, but I want to show you how the procedure works even when we know the answer, and then that helps us lead us into problems where we don't know the answer. Eventually, we won't ask you to show the work on these, but to start out, we do want to see the work, and you want to show the step, every step as you go on these first tests. On this case, we want to divide. Notice when I was doing the subtraction and addition that I showed that underneath with a plus or a minus. In the division, I'm going to show that by using a fraction bar underneath the 2, because I'm going to divide that 2 by itself. What I do on one side, I have to do on the other. So I'm going to show that in between the numbers. 2 divided by 2 gives me 1. That, again, is the part that cancels, that undoes each other. In this case, remember that when you divide a number by itself, it gives you 1. And 1 times x just gives me the x. Then on the right-hand side, we want to finish the problem. 14 divided by 2 to give me 7. If we're given a division problem, a common way we write that, well, let's erase that 3. That didn't look very good. A common way to write that is x over 3 equals -5. And because multiplication and division are undoing each other, where on the first example we divided, in this example we're going to multiply. So I'm going to take and I'm going to multiply both sides by 3. And remember, this 3 is really 3 over 1. I won't generally write that 3 over 1, but I wanted to here for you to see that what we're really doing is dividing by 3 and multiplying by 3. Those 3's cancel. And we're left with 3 divided into 3 is 1. 1 times x is x. And then on the other side, that 3 is about to disappear there, but it's -5 times 3, which would give me -15. Let's look at another example. Eight x plus 4 times 4x equals 48. In this case, we will have to do some simplification first. And in this case, we always want to follow our order of operations to simplify before we start undoing to solve for x. And to simplify, the first thing we'd want to do is to look at that 4 times 4x. And to simplify that, we'll get 16. Then we have 8x plus 16x equals 48. The next thing we see next, Next, we want to add our like terms. The x's are the same, so we want to add 8 and 16 give me 24. We have 24x equals 48. We want the x by itself. We've simplified as much as we can, and it's a one-step problem. To get the x by itself, since it's 24 times x, we want to divide both sides by the 24. Notice as we do this that we don't put the x on the bottom. We're not trying to get rid of the x. We're trying to divide and get rid of the 24. 24 divided by 24 gives me 1. 1 times x gives me x. And 48 divided by 24 gives me 2. Okay, let's look at an example that involves fractions. -2/3 a equals 18. Now, this is a multiplication, so we could divide both sides by -2/3, because that's -2/3 times a equals 18. But dividing by -2/3 gets ugly, as you can see by looking at the picture and at the screen. So we want to come up with a way that's a little bit easier. So what I'm going to do is take my eraser here, and we'll erase that out. Because remember that when we divide by a fraction, that's the same as multiplying by the reciprocal. And let me show you what I mean. If I multiply by the reciprocal here, and the reciprocal of -2/3 is 3/2, and it needs to keep its sign, so I'm going to keep the negative sign out front. And again, remember that what we do to one side of the equation, we're doing to the other side so that it undoes it and keeps the balance between the two sides of the equation. One way that I remember that and tell students to remember that is that if you have two kids, if you bring something home for one of them, you better bring home something for the other. Otherwise, you have a fight and things aren't balanced. So you always treat both sides of the equation the same. So in this case, I've treated both sides of this equation the same. I've multiplied by the reciprocal. And remember, the reciprocal just means that you flip the fraction. The 3 goes on the top and the 2 goes to the bottom. Now, the sign stays the same. So I kept the sign out front. It doesn't have to stay with the 2 as long as it's just out front. Now, when I multiply this, notice what's going to happen. The 2 is going to cancel into the 2. The 3 is going to cancel into the 3. And I'm left with a -1 times a -1. Because remember, when everything cancels, it's really like everything's canceling to be 1. So it's -1 times -1, which is a +1. And +1 times a gives me a. And that leaves the a by itself. So instead of dividing by the fraction, we're going to go on and change that dividing by the fraction to multiplying by its reciprocal, which is the procedure for dividing by fractions. We're just going ahead and multiplying by the reciprocal. It allows us to cancel everything on the left and get that a by itself. Now let's look on the other side. That gives us 18 times -3/2. Remember that any whole number can be written over 1. So that's really 18/1 times -3/2. So to simplify this one, we want to see if anything cancels. So the 2 goes into itself 1 time, 2 goes into 18 9 times. And that allows us to simplify our problem before we go on to the next step. Then we have 9 times -3. 9 times -3 gives us negative 27. And that gives us the correct answer. And you can use your calculator to check it, multiplying negative 2/3, and that is a 3 down there, times negative 27, and when you do that on the calculator, it indeed will give you a positive 18. Now these are just a few examples of one-step equations. If you're still struggling with them and need some additional help, please stop by and see us in room 222 of the Math and Behavioral Social Science building. Thank you.